Hi everyone, I'm Amy. I'll be talking about my dissertation today, which focused on the invasive Himalayan wineberry or Rubus ellipticus in Albany, Auckland. So this plant is currently listed under Auckland Council's low incidence pest plant program, but there's limited knowledge of its behaviour in New Zealand and uncertainty around the most effective management options for the species. So today my presentation will explore why this species poses a risk to New Zealand's biodiversity, drawing on global case studies. Also talking about our local survey and ecological insights, and introduce a species distribution model to help understand its potential spread in New Zealand. Okay. So the project goals were to create identification guides to aid in early detection of Rubus ellipticus, identify the presence of Rubus ellipticus in Albany, Auckland, assist Auckland Council with potential management options, and determine the potential spread in New Zealand under current and climate change scenarios. So what is Himalayan wineberry? It's a species native to the Himalayan region of Asia and thrives in a variety of different environments. So just to go back, it extends from northern India to central and southern China, and its adaptability is demonstrated in its South and East Asia range, where it thrives from high mountain peaks to low elevation rice fields, and in China it had an elevation range of 300 to 3,000 meters, which indicated a tolerance to tolerate frost. It's invasive in a range of different countries worldwide, which include America, the United Kingdom, South Africa, and Australia, and it is considered one of the world's top 100 worst invasive species, and it was first found in New Zealand in 2019 by Peter DeLange. So a common issue that we ran into during our survey that I just wanted to show some light to today was the fact that Rubus ellipticus is really being commonly misidentified as blackberry, which is a common weed species in Auckland. So I just have some images here. As you can see in image B, Rubus ellipticus has a very distinct red fuzz on its stems, and this is the main way to identify the species. This is quite important because if people are misidentifying Rubus ellipticus for blackberry in other regions, we won't be able to fully understand its spread across the country and therefore won't be able to manage it effectively. Another way to tell the difference, you can see in image E, blackberry has more of a pale underside, but the main way to tell it apart is through the stems and the distinct red bristles. So to go more into the identification, the plant can grow up to 3 meters in height, and it once again has the distinct red bristles. The branches are brownish purple with thick glandular hairs and curved prickles. The leaf structure, they typically grow in 3 leaflets and can form dense thickets that can grow to be several meters wide. It's never been spotted fruiting or flowering in New Zealand, but just in case, I thought I'd go over, the petals are white and the fruit are golden coloured. So Himalayan wineberry is of a concern to New Zealand biodiversity due to several characteristics that make it a highly successful invasive species. Its seeds can remain viable in the soil for extended periods of time, which promotes rapid spread, while its fast growth rate and ability to regenerate via underground shoots makes the species very difficult to control. It thrives in various environments, predominantly disturbed areas, from roadsides and sparse forests to mountainous regions. It's indicated to have a tolerance for frost as well as high precipitation levels, and this allows it to invade very diverse ecosystems. Himalayan wineberry also poses a risk to potential agricultural productivity due to its invasive qualities. So similar to blackberry, which is a related species, which disrupts the forestry industry. The species has the potential to compete aggressively with crops and pasture species for sunlight, water, and nutrients, which could lead to reduced yields and lower quality forage for livestock. And its presence may also increase production costs as well, just through land management. So we've really seen the impacts of Himalayan wineberry in Hawaii, where it significantly impacted native environments by reducing the understory forest diversity by 60% in the areas where it was found compared to where it wasn't. and it's threatening native species there, such as the Hawaiian raspberry, Rubus hawaiiensis. The plant has a tendency to grow dense thickets, which creates unnatural shade and disrupts the lower level canopy plants. And given these traits and its documented impacts in other areas worldwide, such as South Africa, the presence in New Zealand is concerning. So, dispersal. So why and how has it gotten to New Zealand? It's naturally dispersed through seeds by birds and mammals, and the seeds can remain viable in the soil for extended periods of time. It's also been spread through human-mediated spread. It was first introduced worldwide in the 19th century for ornamental and agricultural purposes, but it also has medicinal purposes, and pharmaceutical studies have found that it has anti-inflammatory and antibacterial properties, and it's also been associated with different cultures worldwide as well. So it was first found in New Zealand in 2019 by Peter DeLange in wasteland bordering Gills Road in Albany. This naturalization is similar to other countries such as the United States, where we think it's been deliberately planted for agricultural or research into the fruit as a commercial product, and this was actually confirmed in 2019 when an Auckland Council survey found the fruit on North Shore Golf Course, which used to be a orchard for research. So we conducted a field survey to identify the spread of Himalayan wineberry in the Albany area to carry on from the Auckland Council survey in 2019 and the last control efforts in 2022. So we followed a 10-metre transect method, which was previously established in the last council survey, and we used Esri's field map software and recorded the observations and mapped the data points for the areas that were assigned to us by Senior Biosecurity Officer, which was based on the predicted occurrences from the previous survey. So the key sites that we found Himalayan wineberry were in disturbed urban areas such as Snapper Road, the North Shore Golf Course, and the Albany Village. It was observed alongside a variety of species like native plants like silverfern, carnuka, manuka, and supplejack, as well as invasive such as climbing asparagus, woolly nightshade, wild ginger, and blackberry. So North Shore Golf Course had Himalayan wineberry growing with plants such as arum lily, which indicated that this plant may have a preference for more wet and disturbed habitats. And then in the older undisturbed forest areas with remnant species such as Rimu, Totala, and Nikau palms, Himalayan wineberry was absent. So this indicated that these stable ecosystems with well-developed native vegetation seemed less susceptible to invasion. So here you're looking at a graph of the adults versus seedlings that we found in the survey. So as you can see, there's a significant amount of seedlings compared to adults, and this just really indicates the reproductive capability of mature Himalayan wineberry plants. So whenever we found one adult, it would always be surrounded with a number of seedlings. And then the next images are from the North Shore Golf Course, which had the previous removal attempt in 2022, and we did find the plant regrowing here with adults and seedlings, which follows what studies found in Hawaii and South Africa, that it is able to regrow from control attempts. And here are the overall points of the survey. Okay, so for the last part of the study, we wanted to explore the potential spread Himalayan wineberry could have across New Zealand to help inform management of the low incidence pest plant. We used geographic information systems to predict the potential future areas Himalayan wineberry would invade in New Zealand. The current occurrences are obviously quite biased because the surveys have only been done in Auckland and predominantly just represent what we found in this survey. So because of this, we consulted with experts and we landed on an analogue species, Rubus verniculaceus. We landed on this species because of the similar field associations and the fact that it's the only other member of section A Dabitus that is already established in New Zealand. And as Himalayan wineberries relative, the current distributions can offer us valuable framework for predicting the other regions that may be potentially at risk, as well as advising management on an early identification. So we obtained the Japanese wineberry occurrence data from GBIF, which was cleaned and analysed in ArcGIS Pro, and then we used Maxent to do the species distribution model and sourced environmental data from WorldClim, first testing 19 variables and then using the top 5 variables that contributed to the model over 1%. The variable there, number 9, is the annual precipitation, which can kind of give you an idea of the species. And then we also sourced the future data from ICPP's 5th report. Okay, so this shows you the current, this shows you Japanese wineberry spatial data. So you can see that the occurrence data is quite evenly spread over the North Island with limited occurrences in the South Island, with the high occurrence areas being the Waikato, Bay of Plenty and Nelson. And then an optimised hotspot analysis found hotspots of 95% and 90% confidence in Nelson. This is the species distribution model for the analogue species under the current climatic conditions. So you can see in red, this is the areas that were predicted to be most highly suitable for it to grow, and purple is the lowest. So it predicts moderate to high suitability in the Auckland, Manawatu and Christchurch regions. The next image shows you the overall predicted presence in yellow and the absence in red. So this is the presence, it's all the presence regardless of if it's a high or moderate strength predicted. And then this is the future climate change data. So for these species distribution models, we used future climate data for the year 2070 under 2 different representative concentration pathways. The first being RCP 2.6, which is a low emission pathway, which has a predicted temperature rise of 1.5 to 2 degrees Celsius, and then RCP 8.5, which is a high emission pathway, which shows a future with consistent fossil fuel use and a warming of 3 to 4.8 degrees Celsius. So these scenarios can provide a framework for understanding how different climate futures may influence species distribution. So under the year 2.6, you can see further expansions into the regions in the current model, as well as further expansion into Taranaki and Hawke's Bay and the South Island distribution, expanding into the west coast. And then the high emission pathway shows the distribution expands even more and becomes more highly suitable in the North Island. And here's the same data under the absence and presence data again, so you can see it's predicted to be more suitable under a higher emission pathway, but both show significant presence. So overall, using an analogue species highlights areas where Himalayan wineberry may potentially spread, which can inform optimal management strategies. We expect Himalayan wineberry to follow similar patterns given the similarity of the 2 species, and this study will hopefully aid in early identification through identification and of new areas. The main areas that we've highlighted through this is Auckland, Waikato, Bay of Plenty, Nelson, Blenheim and Christchurch. And it can also give us an idea of the future implications of where this plant could grow if no management efforts were in place. So to talk about the management, Himalayan wineberry is currently predicted to be in between the lag phase and the exponential growth phase. We think that eradication now would be the most feasible to avoid the long-term costs, but we do need to be realistic about the current climate of Himalayan wineberry. So there was a new plant that was spotted in Mount Albert recently, which is quite concerning as it was thought to be contained to the Albany area. So the Ministry for Primary Industries determined a few years ago that Himalayan wineberry was already too well established for national eradication to be viable, and then management was then passed to Auckland Council. So while progress has been made at the known sites limited resources have meant that the potential habitat has not been fully surveyed. So unfortunately, the species has been present in New Zealand for decades, which has allowed for undetected sporadic spread. And the discovery of the new plant at Mount Albert has confirmed this. So although the council has significantly increased its pest plant eradication budget and improved data collection, the assessment has concluded that the current efforts for Himalayan wineberry are actually only slowing its establishment rather than reaching eradication, which was the original goal. So complete eradication would require intensive, repeated grid searches around all the known plants, which is currently unfeasible given the number of other high priority pest plants already in the program. So I'd like to note that Auckland Council is still going to continue the control and the searching in the Albany area, and that this case has provided valuable lessons that are now being applied to the future species incursions in the program. So I'd like to just thank Auckland Council for funding this project, as well as Lydia Starr and Kelly Wooten for assisting us with the fieldwork. And thank you for listening. That's all.
No, Mindy, thank you very much, Adam. Any questions?
Yes.
Your climate modeling, I might have been reading the map wrong, but it seemed like Auckland was actually a fairly low suitability area based on the model. Is that, am I seeing that correctly? That it's blue up there?
Yeah, like it's slightly lower. Yeah, it's not like in the red.
Then that if it spreads south at all, it's going to become a more serious pest, or?
I guess so, yeah, and that just comes back to the identification as well, that it's only been spotted in Albany, but because it's been present here for decades, it could already be present and people just haven't spotted it because it might not be a recognisable species. So that's why it's, I guess, important to just spread the word, and if anyone does see it, to report it, and then we can get a better idea of where it could be and hopefully get better modelling in the future when we get more data. Yeah. Yes.
I have two questions. One is, you simply just use the overseas occurrences to do the climate modeling in New Zealand?
Yes.
You have to have a proxy?
Mm.
And then the other question was, how long before it produces seed from seeding that?
Okay. The first question, we did think about that, and then we talked to the experts about it, and their opinion was that if we use the overseas data, it wouldn't be, I guess, suitable for New Zealand because of the different climates, is what we were told. So that's why we went for the analogue species instead. But yeah, that was the advice.
So that's time for Amy. Who can give us the easiest ID compared to Blackberry? That was like half the point of what she was talking about. Can we idea?
Oh, sorry.
Thank you very much, Amy.